Today's lesson is over dilations, and so what I wanted to start off with was a real world example of a dilation. Now, you've seen this eraser around the classroom if you are familiar with Ms. Gable's class. It's rather large, but then we have a smaller version from apparently Staples. So the thing is that when we talk about dilations, we like to talk about how much bigger something is compared to something else, or how much smaller something is compared to something else, given the erasers. So the thing is that if you were going to make a guess about how much larger the bigger eraser is in terms of the smaller eraser, you may say something like it's about, I don't know, 5 times bigger. And so that's an easy scale factor, and that's the number that 5 represents as a scale factor. So we could say that this eraser, the purple eraser, is 5 times larger than the pink eraser. But the question becomes, how much smaller then would the pink eraser be compared to the purple eraser? So we said it is 5 times bigger. How much smaller would it be if I was comparing things, the smaller one compared to the bigger one? So that's the whole purpose of the lesson today, is for you to be able to understand the difference in dilations. Of course, we're going to talk about pre-images, and we're going to put it on a graph. So what I have for you right here is going to be your notes. Yes, handwritten notes by yours truly, your favorite teacher. Just joking. But for real, hold on one second. What you have here is the definition for a dilation. A dilation is a transformation in which a figure is either enlarged or reduced with a fixed point C, and C would be our center of dilation. Now, for the purpose of this class, we'll do our dilations based off of the origin and a scale factor of K. K represents how much bigger or how much smaller, which is the ratio of the lengths of the corresponding sides of an image. And notice I put a little prime there, and the pre-image. So do I want you to write that down? Yes, I do. That's the definition for a dilation. Now, the dilations preserve the shape, but not the size of a figure. So also the angle measures are preserved, meaning they remain the same. Like, for example, the erasers. If I go from the bigger one to the smaller one, the shape is very similar to the other, but the size change. And that's all that's meant by the shape stays the same, but the size does not. As far as the angle measures, if I say that this angle here is maybe, I don't know if you can see that, but if that angle is about 45 degrees, then the angle measure here would be somewhere around 45 degrees for that. And then something else that's important, angle measures will stay the same, but let me move this paper up. When K is greater than 0, we would say that an enlargement occurred. Okay, so, but if K is between 0 and 1, that means, yes, we're going to have fractions. We might even have decimals to represent the scale factor. Then the dilation is considered a reduction. So what I did was, and I don't know if you could see that, but I put a little prime on the big mistakes eraser compared to the pink eraser. And so if we were going to make a guess about it, I could say that the scale factor going from the pink eraser to the purple eraser is 5 times larger. So K would be 5. Now, if we were to switch things around and say, well, how much smaller is the pink eraser compared to the larger eraser? So now this is my second image, the smaller eraser. I would say if I was going with the same number 5, instead, ta-da, it would be 1/5. So a reduction, like you have on your notes, and I want you to pause the video so that you can get this down. But this is really the most important part of the notes, is that a dilation will preserve the shape. When K is greater than 1, it's an enlargement. If it's between 0 and 1, then it's a reduction. So for me, a reduction would be 1/5 of the size, and a scale factor of 5, then would be an enlargement. And I'm going to hold the paper there still so that you can record some notes. Hopefully, you can see it. Pause the camera if you need to get everything down. But what's highlighted, you really need to have in your notes. Okay, so what you got? Okay, so I'm trying to do my best for what I got. So I'm trying to see if I could get a little bit bigger. Okay, so the directions say find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. So when you look at the picture, our center of dilation is C on both of those, and our pre-image is the one that's a solid shape. So on number 1, it's the quadrilateral down at the bottom, and on number 2, kind of similar, but it's also the quadrilateral at the bottom. But what you notice here, going from P to P prime on number 1, the image is actually getting smaller. So without even looking at the scale factor, we know it's a reduction. And then that way we know that our scale factor needs to be a fraction, or less than 1 but greater than 0. So our fraction that can represent our scale factor here is going to be 2/4. Which 2/4 can be reduced to a half. So our scale factor here, I'm safe for saying that it's a half. Okay. Then we have on the other side a triangle that looks as if it's gotten larger. That's the dotted lines right there. And so since it's gotten bigger, this one is an enlargement. And our enlargement is actually going to be the ratio of 25 to 20. Which can be rewritten as 1 5/20 as a mixed fraction, or we can write it as a decimal if you prefer. Okay, so like I said a second ago, you can write it as a decimal if you want, 1.25, or you can leave it as a mixed fraction. It really doesn't matter which one you do, just as long as you know that an enlargement will have a scale factor that's greater than 1, and our scale factor here is 1.25. That lets us know that we did it right. Okay, so the next problem, number 3, it says coordinate rules for dilations. Of course, we was going to put it on a graph. So it says if the center is at 0, 0, then what you can do to find out the new location of P prime is you will multiply each x term and each y term by the scale factor. So given the problem that we have here, it says graph the polygon and its image after a dilation centered at C with a scale factor of 5. Now we got fortunate on this first one. Our center of dilation is the origin, which is located at 0, 0, and our scale factor is 1/5. Now if you look at all of the points that we have here, P, Q, R, and S, they all are a multiple of 5. So what you can do to find all of the new points is just multiply it by 1/5 or just divide by 5. That's the same thing as a scale factor of 1/5. So I'm going to do the first one with you. So P prime, if P is at -10, 0, then what I would do is I would multiply 1/5 times that same -10, comma 1/5 times 0. And that would tell me the location for my new point. So P prime would be at, it's a negative, so it's a -2. And 1/5 times 0, or anything times 0, is just 0. So P goes from being at -10, 0, and we're making it 1/5 of the way. So I hope that when you saw 1/5, you also thought that this is going to be a reduction. It's going to become a smaller figure. So -2, 0 would be 1, 2 right here. And so now I have P prime located there. Oh man, we can't see the whole page. Okay, so give me 1 second. I want you to try to do Q, R, S, and we're going to talk about where those belong. Give me just 1 second. Hopefully, after you have multiplied all of your points by 1/5 or just divided everything by 5, you came up with Q prime, R prime, and S prime being at the locations that you have here. I'm going to pause the video for a second just so that I can write down or show you, draw the image on the graph that's there. Okay, so I plotted my points on the graph that we had, and what happened is we had a very much smaller graph of a quadrilateral PQRS, and I'm just coloring it in just in case if you can't see it well enough. But none of the points rotated or flipped around or anything like that. We went from P being at the bottom on the left to P being on the bottom at the left. Q being at the bottom on the right, bottom on the right. So we didn't change the orientation of the shape at all. All we did was reduced it by way of dilation. So the next problem, number 4, is to find the coordinates of the image of the polygon after a dilation centered at the origin, which is 0, 0, with a scale factor of k. So we're doing the same thing. The only difference is here we don't have a graph to do. But if you want graph paper, you know I got graph paper for you. So what's going to happen, I'm going to do the first one for you or with you. Hopefully what you see, given that P is at a -2, -1, I'm going to take my scale factor of 4, which is given, and without even trying to figure out the problem, if the scale factor is 4, what should it be? Should it be a reduction or an enlargement? Hopefully your thought process is telling you that it should be an enlargement. If you thinking reduction, just playing. It's the beginning. So we multiply every single value by 4. So P prime will be 4 times a -2 because that's the X value, and then 4 times a -1 since that's the Y value. Now, don't be talking about how I'm closing parentheses. If you open them up, you got to close them back, okay? So the location for P prime is then going to be 4 times a -2, positive times a negative is a -8. Okay, and positive times a negative again, 4 times -1 is going to be a -4. So the location for P prime would then be -8, -4. Now I want you to do Q and R, and then I'll come back in a second. So pause the video. So that should be your thought process as to where you put the rest of the points. If something is not right or if you don't agree, please say something so we can discuss it in class. Okay, the next one, number 5, is you design a poster on an 8x5 inch on an 8.5 inch by 11 inch paper for a contest at your school. The poster of the winner will be printed on a 34 inch by 44 inch canvas to be displayed. What is the scale factor of this dilation? Now, hopefully, when you read that, you thought that this was going to be an enlargement, because we're going to take a smaller piece of paper and make it bigger so everybody could see it. And then on top of that, let's take a pause and draw it out. Okay, so the paper goes from 8.5 by 11. This is going to be your pre-image. And then it gets to 34 by 44. So if you're like Miss Gable, I know you don't want to deal with that 8.5 and the 34. But we already know that it's going to be an enlargement. So question, would it make sense to write the fraction for the scale factor as 11 over 44 or 44 over 11? Take a second, think about it. The correct answer for this would be a scale factor of 44 over 11 because 44 over 11 would reduce to 4. So the scale factor for the enlargement would have to be 4. Okay? All right. Now, number 6. Number 6 is something that's kind of relevant to you. A biology book shows the image of an insect that is 10 times its actual size. So the book blew it up. The image of the insect is 8 centimeters long. What is the actual length of the insect? I get to talk about my picture unless yours is better. So we have an insect is 8 centimeters long inside of the textbook, but we know that it's 10 times its actual size. So the thing is that the actual length of the insect is going to be smaller. So that would be a reduction. Okay, and our only two numbers that we have is 8 and 10. So could we express it as 8 over 10 or 10 over 8? Hopefully you went with 8 over 10, which is the same thing as 4/5, or the same thing as 0.8. Take a second, pause the video, write that down. But that's going to be it. All I have for you is 6 practice problems. Remember that tutoring is Monday and Thursday from 3 to 4 p.m. Use Canvas and Big Ideas Math for your practice. Miss Gable loves you.